Okay, the next part of the video is when height is increased, what happens to the total amount of energy? So we've set up this system exactly like before. We've got mass right now at 5 kilo, left gravity and friction alone, ticked these two so that we've got speed and sticking to the track, made sure it's on play there. And you might notice that I've actually put the height here quite low. This skater right now is at 2 meters in height. And of course over here you're going to be having your graph, but I've cut that out because I want you to go and have a look at that and not look at my screen here. So I want you to answer the following questions. When you change the skater's height, what happens to the total amount of energy in the system? So you're going to be first setting them at 2, and then I'm going to get you to set them up here at 4 meters and then at 6 meters, and have a look at what happens to the total amount of energy in the system and answer those questions. The next thing you're going to be doing is, instead of changing height, we're going to change mass. So in this case, we need to keep height the same. So we're going to leave height, or their starting height, at 6 meters. And you're going to look at what happens when we change the mass of the skater. So again, everything else is set the same, but I want you to change the mass up. Now you can either type it in here, right there, or you can click the little play button there to move it along. But I find the most important thing when you change any sort of variable is you try and do it in lots of the same. So I try and always go up in like increments of 5 or 10, but more specifically I try and look at what happens when I double or triple or quadruple something. So I need to have gone up in increments enough that I've actually seen what happens when the variable I'm playing doubles, and if possible triples and quadruples, because we're trying to see if there's a mathematical pattern to it. So in this case specifically, when you double mass, does that double energy, or does it do something even more to energy? So let's have a look at how I want you to set up. You're going to, again, look at your graph and measure or look at the kinetic energy, the total amount of energy. If you really want to check it out carefully, you may, I haven't tried this yet, you may be able to use your measuring tape even there to measure the height of that energy on that graph. And then I would suggest you go up in increments, but definitely I'd say go up in lots of like 20 kilos, or 10. So 10 kilo, 20 kilo, 30, 40, 50, 60, 70, all the way up to 100 kilo. And if you really want to collect data well, you could even measure it with your measuring tape, but you need to answer the question, when mass is increased, what happens to the total amount of energy? And then we have one more question at the end here. So the last question is, how would you describe the relationship between potential energy and kinetic energy? How do they relate to each other? When one of those changes, what happens to the other type of energy? You need to answer that question in your Google Doc. And then after you finish that simulation, you can do some playtime on the simulator if you want, as long as your teacher says you've got time. But don't worry, we'll also come back and revisit skate park physics for future activities as well.